All right, guys. So since we're on this paper, January 2023, kind of makes sense we just take questions from this one now, since it's on the screen. So, which of these questions you all first want me to do? Explain. Hold on. Somebody online saying something. I'm not hearing. Hold on. Hold on a second. I'm not hearing. Speak again online, let me hear. I don't hear whatever.
Yes, sir.
All right, yeah, here now. All right, so somebody said number 6 in the classroom. So somebody online called a question a while ago. Why not hearing? I'm not hearing online. I hear somebody say yes, sir, but. Hold on. Okay. This is confusing. All right. So number 6, right? Number 6 on this paper. Let's see what question that is. Number 6. Number 6. Number 6. Oh, this one. All right.
Sir?
Yes?
For the total length, it is going to be 22/7 times 49. And then after...
No, you don't have to preempt it now. I'm just going to do it. So you can just check your answer that you have against what I'm going to do. That's okay. So I'm going to go through it and you just check your answer that you have. I mean, if I were to listen to everybody's solution, they wouldn't finish, right? So let me just go through it, and if you disagree, you can let me know. If you agree, well, fine. All right. So this question starts out by telling us to take pi as 22/7. So once you see that, you know that we're going to have to be doing some circular measures. All right? Because this relates to circular measures. It says the diagram below shows a scaled drawing of a running track. It consists of a rectangle and 2 semicircles. So these 2 semicircles together really make a circle. All right? It says the diameter Ln and MP such that Ln equals MP is 49. So the diameter here is 49. But we tend not to work with diameters when we're doing these things, these questions. Hey, tell them over there to be quiet for me now. So I don't want them over there. So I'm going to write down that the radius is 49/2. 49/2 is how much? What is 49/2? Huh? How much? 24.5 centimeters, half of the radius, half of the diameter. So we're going to be working with this as a radius. All right, so that's meters. And then this length is 98. So this length is also 98. That's what it is saying here. Question said we have to show that total length of the running track is 250 meters. That's the distance around it. So quite simply, that total length is going to be equal to 2 times this length, 2 times the long side, which is 2 times 98, plus this arc plus this arc. That's 2 half circles, which really makes a circle. Huh? Well, the same link. Oh, hold on. The same link from the. Hold on a second. Hold on, I'm sure. Hold on. Sorry about that. Let me just share this quick. Hold on a second. Code is 194,916. 194,916. All right, so about that, guys. So I didn't send the link to some students, right? So I'm going to say it's basically 2 half a circles, make a whole circle. So we can just write 2 pi r. Because this would have been pi r anyway, and this equal pi r, those 2 arcs. So basically 2 pi r. I'm just going to write 24.5 here, right here for the radius. I'm going to put the formula here, which is 2 pi r. So that's what this is, 2 pi r. All right, remember the pi is 22/7. And so we can do this calculation and write the answer. Let's put on the calculator. So it's 2 times 98 plus 2 times the pi, which is 22/7, times the 24.5, and we get the nice even 350 meters. And that is it. And we can say here that we use pi as 22/7. All right, so far so good, right? This is the easy part, but I got that. Next part says, Nathan walks at a rate of 1.4 meters per second. This is not complicated. All it means is that every second he walks 1.4 meters. Can be done as a ratio, can be done as speed equal distance over time relationship. All right. It says calculate the time it would take him to walk 7 laps. So the first thing we need to know is what the total distance of 7 laps. You can go for speed equal distance over time and then calculate the time taken to walk that total distance, or we can work this as a ratio and multiply up to the 7 laps, the distance. All right. So let's use speed equal distance over time. I think that's what most persons would do. But firstly, the 7 laps, the distance for 7 laps. So the distance walked is 7 times 350. That's the total distance that he walked. And we can work that out. We don't have to, but we can work it out. And that is, he walked 2,450 meters total. Then what we know is that this that they gave us is the speed. That is the speed. And we can use a formula that says speed equals distance over time. And we are trying to find time, right? We need to make time the subject of this equation. We can multiply up the time and divide under the speed. And so the time is going to be equal to the distance over the speed. And the units are consistent because the distance is already in meters and its speed is in meters per second. So we're working in meters and the time is going to be in seconds. So this becomes 2450 divided by the 1.4. Our answer is going to be in seconds. All right. And they didn't tell us what unit to use, so we can give the answer in seconds. So here it's just a matter of dividing by 1.4, 1,750 seconds. And you have to say seconds. That's 1750 seconds. All right, so I chose to do it this time. If you look at the video, you might see a different method. All right, I think the last time I did this question, I used a different method. All right, but let's keep this method for today. More maths equals better maths. All right, next part says, so Tafari runs 1 lap of the track in 68 seconds. So it takes 68 seconds to complete that one lap. Remember, the one lap is 350 meters. All right? So remember, the one lap is really 350 meters. 350 meters. Let's not forget that. So that's the time he takes to run this distance. Or, yeah, he's running. He's running. He says, determine the number of laps the far right can complete in 1 hour. Determine the number of laps he can complete in 1 hour running at the same speed. Now, this can be done multiple ways. We can find out how many 68 seconds exist in 1 hour, right? And that will basically be the number of laps because he's doing one lap in 68 seconds, right? So we can say how many 68 seconds exist in 1 hour. We would have to break the 1 hour down to seconds and then divide it by 68. That will give you the number of laps, all right? The second way to do it is to actually just take this ratio, 1 lap to 68 seconds. I'll put it the other way. 68 seconds equals 1 lap. And you build this 68 seconds up until you reach 1 hour. You can do it that way as well. All right?
Should be 3,600.
All right. So
seconds.
Somebody says 3,600. All right. My question now. So, oh, you're saying this is 3,600 seconds, this?
Yes, sir.
Okay, all right, good. So first they want to know the total time in seconds, right? So time in seconds. And again, if you watch the video, I'm deliberately doing it a different way today now because I did it another way when I did the video. I remember when I did this question the last time, I did it another way. I am deliberately doing it this way now, different from the last time. So if you look at the video, it's a different method. All right, so the time, which is 1 hour, is 60 minutes, which again is 60 times 60 seconds. So it's correct. That's the total time in seconds. And he's doing 68 seconds per lap. So therefore, the number of laps, I don't have to work this actual figure out, I can keep it there. It becomes 3,600, yes. But I can say, therefore, say the number of laps would be that 60 times 60. If you want to put the 3,600 divided by the time for 1 lap, which is 68. And that will give you the number of laps. So it's a 52. Fraction. 60 times 60 divided by 68. And that's 52.9. And look here now. You have to be careful now. So we're getting 52.9. But the question says, how many laps he completed? See this word? Very important. Complete. So since he's doing 52.9 laps, he has completed 52. So the answer is 52. So don't go put in 52.9 as your answer. All right? So you have to be careful with these things. You see, usually when a question asks for this, the number of something, this phrase right here, the number of something, number of, your answer usually is a whole number. Counting number, natural number. Number of something is counting. 1, 2, 3, 4, 5. So when the question asks for the number of something, you're looking to give your answer as a whole number. So think about it. So the number of laps completed. He did 52.9 laps. He failed to complete the 53rd lap. He did not actually finish the 53rd lap. So you actually completed 52 laps. So this is 52. Let's write it out and say what the key thing is on this. All right. So here, this would be 52.9 laps in this time. But you're going to say completed. $52 laps. And this is your answer. Answer is 52. All right? And you don't round it up to 53. You have to be smart. Don't round it up to 53 because it's 52.9. You did not actually complete 53 laps. So you cannot round it up to 53. He completed 52 laps. All right. Next part says, Nathan completes running 1 lap of the track every 72 seconds. So he's going slower than Tafari. It says Tafari and Nathan start running at the same time from point L on the track. So one running at 68 seconds per lap, one running at 72 seconds per lap. So there's a 4 seconds difference right there, right off the bat. 4 seconds difference. It says each complete a number of laps of the track. Calculate the least number of laps that each will complete before they are both at L again. All right. So listen to this now. The first thing is that 4, remember, Tafari is doing 68 seconds, right? That's right, T for Tafari is doing 68 seconds per lap. And Nathan is doing 72 seconds per lap. So this is kind of nice because 68 is a multiple of the difference between the time of 4. And 72 is also a perfect difference, perfect multiple of 4. So he is doing 4 seconds slower every lap than Tafari, while at the same time, Tafari is doing 4 seconds faster. So look at it this way. Every lap, Tafari is going to go 4 seconds more ahead. So the first lap is going to be 4 seconds ahead. The second lap is going to be 2 times 4 seconds ahead. The third lap is going to be 3 times 4 seconds ahead. You understand? So he's doing 4 seconds more per lap ahead. But the beauty about it is that eventually he will have that 4 seconds. You want to know how many 4 seconds are there in 72 seconds? Because he needs to do that same number of 4 seconds to add up to the 72 seconds, which is equivalent to 1 lap that Nathan is going to do. And the reverse is true. The reverse is true. You want to know how many 4 seconds is in his time, because he now is going 4 seconds slower per lap. So they are going to meet at a common multiple of 4. Right? So the question first is, which one of them is going to run less laps? Because it says Tafari will complete how many laps, Nathan will complete how many laps. Somebody tell me, based on this, who's going to run more laps? The one who's going faster, the one who's going slower? Which one going faster? Can't be Nathan going faster, my boss.
Sorry.
Nathan is taking all of 72 seconds to finish a lap. So he's going slower.
Tafari,
so Tafari is going faster. So Tafari is going to do more laps. You understand? He's going to do more. So the number of laps that Tafari is going to do is going to be this number divided by 4. Because his number of laps, you want to know how many 4 seconds is in the 72 seconds required by Nathan to complete 1 lap. You want to know how many 4 seconds is in Nathan's 72 seconds. That's 1 additional lap that he's going to do. Because the 4 seconds that Tafari is doing more than Nathan, he has to do that equivalent number of laps to match 1 lap that Nathan is doing, which is 72 seconds. You want to know how many 4 seconds are in 72 seconds. That's when they will meet again. You understand what I'm saying? Because he's doing 4 seconds faster every lap. So to meet what Nathan is 4 seconds must add up to the time that to a 1 lap equivalence for Nathan, which is 72 seconds. So see here, so Tafari's time. This is Nathan's time, you know. But Tafari's laps. This is going to be Tafari's lap. Let's write T laps. T's laps. Just to keep it simple. T's laps is going to be 72 divided by the 4 difference between them. 72 divided by 4. And this now is going to be Nathan's laps. Right? because Nathan now has to do a number of 4 seconds difference that add up to the 1 lap that Tafara is going to do in terms of the time, 68 seconds. So you go both ways. So one is going to be 1 lap more than the other. Why? Because the difference between these two numbers is 4, and you divide each of them by 4, right? And that's the beauty about this, because 4 is a perfect factor of the two numbers here, right? So this now is going to be Nathan's laps. Nathan's laps.
Sir,
Yes.
how do you know that they're doing 4 laps each?
I didn't say they're doing 4 laps. I said they're doing 4 laps, 4 seconds difference. They're doing a 4 seconds difference per lap. One doing 72 seconds per lap. The other one is doing 68 seconds per lap. That's a 4 seconds difference. 4 seconds difference. You understand? Each lap. One doing 72 seconds on a lap, and the other one is doing 68. So one is going 4 seconds faster than the next. I'll put another way. One is going 4 seconds slower than the next. So every lap, that 4 seconds is gonna multiply, basically. So the first lap is gonna be a 4 seconds difference. The second lap is gonna be an 8 seconds difference. The third lap is gonna be a 12 seconds difference, right? In terms of where they are on the track, relative to that position that they are passing. Right? Relative to that position that they are passing. So they will meet again when one of them do the total lap time of the other. That's when they will meet again. When one do 1 lap time more and one do 1 lap time less. That's how it is. So when we divide this, we get, how much we get? 72 divided by 4 is how much? 72, how much? 18. And this divided by this is what? Must be 1 less, 17. And that is it. So Tafari is doing more laps. See here. Tafari completes 18 laps. And Nathan will complete 1 less, 17 laps when they meet again. That is the answer. Now, if you look at the video, all right, I did this question 3 different ways than this one I'm showing on the screen now. 3 different ways I did it. If you watch the video, this is a 4th way now you're seeing on the screen. So if you watch the video, you see 3 different ways in the video. This is now a 4th way. All right? All right. Yes? Huh? No? Nathan the more lap, Tafari the more lap, the Tafari run faster. I said this is Tafari's laps. How many laps Tafari have to do? Tafari have to do 18 laps. This Nathan is doing this seconds. Nathan time is this 72 seconds per lap. So Tafari has to match that 72 seconds. Each of the 4 seconds that Tafari is doing faster. He might forget those 4 seconds that will make up to 72 seconds to match the lap time that Nathan is doing. You understand? All right, listen. Just think of it. The one that is going faster is one that is doing lap in a shorter time, don't it? So it's going to do more laps. Tafari, he must do more laps because he's running ahead. Right? The one that is going slow is going to do less laps in the same time. Right? Look at the video. I did a method where I use distance. I did a method where I use time, total time. The result is the same. All right. Which other question you want me to do? Number 10 on this paper. All right, number 10 on this paper. So you can look at the videos, guys. And you see 3 different explanations. What do you want? Write in paper? Huh? All right, hold on. Hold on a second. Hold on. Let me get it. Hold on a second, please. All right. Next question. You all right? You sure? Huh? All right. Yes, sir. All right. Somebody say number 10 on this paper. Number 10 on this paper. Come up here. Want this part of it too? Just the vectors? All right. All right. The vectors question. Let's go. I don't need a calculator for this one. All right. Quiet, please. Question says, in the diagram below, OPQ is a triangle. ARB and AOQ are straight lines. B is the midpoint of PQ. Let's look at it. So this is the midpoint of this line. All right, that's obvious. It's clear. R is the midpoint of AB. R is midpoint of this line. Okay. That also we can see that on the diagram. But then it says OR to PR is 1 to 3. And they're talking now about this line. This line. Divided in the ratio 1 to 3. The point R divides it in the ratio 1 to 3. So a way to know the fraction is really a way of breaking down the fraction of the lines, you know. Breaking the line into parts, really. So what we can do is put the ratio, see the ratio here, 1 to 3. Put the ratio on the line. So OR represents 1 part and RP represents 3 parts. So meaning that the total parts on the line is 4. That's what ratio is. Ratio shows our whole is broken down. So the total parts on the line is 4. So in terms of the entire line, OP, this piece is 1/3, 1/4, sorry, 1 out of 4. So this piece is 1/4 right here. This piece is 1/4 of the entire line. Let's put it. This represents 1/4 of the line. And this, because of 3 parts, this piece of the line is 3/4 of the entire line. Talking about the entire OP. So this part of it represents 3/4 of the entire line. Let's put it up here. This is 3/4 right here. And down here is 1/4. Let's put the 1/4 here. And what I'm talking about this. All right. So don't forget. That is it. So whatever the total vector on this line is. Right? Down here is 1/4 of it. And up here is 3/4 of that total vector, whatever OP vector is. All right? They like to do these things in vectors. All right. That's the first thing you want to establish. Then it tells us, and give you nice numbers as well, because it tells you here that OP is 4A. OP is 4A now. And this is 1/4 of the 4A, and this is 3/4 of the 4A. So it breaks that 4A nicer for us into A plus 3A. Right? Because this 1/4, which represents this piece, is 1/4 of the 4A. So it means that this vector right here, from O to R, is just A. Let me put it up here. 1/4 of A. 1/4 of the 4A. Not 1/4 of A. 1/4 of the 4A. That's what this vector down here becomes. That's what I have here. All right. And then up here now, the vector from R to P becomes 3/4 of the 4A. So let me write it out here. It becomes 3/4 of the 4A. That's what this vector is. 3/4 of 4A is 3A. So that's a total 4A there. See, the OP is 4A. A down here and 3A up here. So you want to establish that before you even get into the question. All right. Then it says the vector OQ is 8B. That's from here to here is 8B. Let's put it on the diagram. So the vector down here is 8B. All right. So you have a vector component. So you know the portion vector of O, because you know O of Q, sorry, because you know OQ. You also know the portion vector of R, because you know OR. And you know the position vector of P because you know OP. You have those position vectors, you can use them. All right. Question says, find in terms of the A and or the B, mean that all your vectors must be with these values or these vector components. When they write them in bold, I tend to underline the vector components. Put a line under this A right here. First question I want, the very first vector I want is PQ. Now, because we know the position vector of the P and we also know the position vector of the Q, you can use that displacement formula, which is O times the last minus O times the first, OQ minus OP, because you know the two position vectors. So it's O times the last, which is the OQ, minus O times the first. Q is the last and P is the first. So the OQ is this vector here, 8B. Minus OP is the 4A up here, 4A. So we can put 4A right there. And that is it. You could have also looked at the diagram. Yes? O times the last minus O times the first, please. When you know the position vectors, that's a quick and easy way to do it. O times the last minus O times the first, or displacement vector. The other way to do it is to look at the diagram and say, okay, how do I go from P to Q? I have to go along the vector direction that I know. These are the vector directions that I know. Those are like roads that I know. So I would come down to O here. But because I'm going into the opposite direction of those vectors, it becomes a negative 4A. So the negative 4A there. Then I'm going from O out to B this way, using the 8B. See there, that's 8B. So we could have put minus 4A plus 8B if we were working from the diagram. It's the same as this. But generally speaking, if you know the position vectors, guys, you just use O times. If you know the position vectors of the endpoint of a displacement vector, the PQ is called a displacement vector from P to Q. That's a position vector because it's a vector from O to the point. That's another position vector, the vector from O to the point. They are called position vectors. All right. When you know the position vectors and you're trying to find a displacement vector, you can use simple equation O times the last minus O times the first, rather than use the diagram. Next question wants us to find PR, which we have it already. P to R, just that we are going in the opposite direction to this 3A. The opposite direction in vectors is indicated with a negative sign. So this is negative 3A. From P to Q become negative 3A. The vector is 3A this way. P to R is the opposite way, and so it's a negative 3A. So this is just equal to negative 3A. No calculation needed. It's on my diagram. Next part. RB. Easy. How do I go from R to B? From R to B. Now, remember, this can be done multiple ways. Remember that B is the midpoint of this line. You know? So essentially, PB is half of PQ. That's what this PB is, you know, half of PQ. And then you also know this vector, R to P. So that's the easy way to do it. To go from R to B, we would go from R to P first, and then go from P to B, using this half of PQ. Why am I using half of PQ? Because we know PQ already right here. Right? Once we calculated PQ in the first part, it is now as if we now know this vector. Like that's a road, we can travel on it now because we know it. It's here, we know this road now. So we can travel along it using that vector. Think of it that way. All right? So we're going to do it that way. We will say, okay, let me write it here on the screen. Just have it in front of us. So we'll set up a vector equation that says to go from R to B. That's what vectors is. Or you go from point to point. to go from R to B is the same as, equal means is the same as. We're going to go from R to P first, R to P first, and then the plus in vectors means, and then we go from P to B. We go from P to B. But the P to B is just half of the PQ. So we're going to write this as RP plus half of the PQ. And half of the PQ is half of this. So we can just complete it right here. The RP is 3A up here. So I'm going to write 3A. And then half of PQ is half of these values. Half of this is just 4B minus 2A. So we can write plus 4B minus 2A right here for the half of PQ. And then cancel the values. So it's 3A minus 2A, that is A, plus, and that's a 4B. So my answer is A plus 4B. Let me copy this down now. That's my calculation down here.
Sir,
Yes?
can you do the wages question?
Wages question. All right. All right. So that is the answer for this one, guys. What I like to do when I get my vectors answers, I like to kind of check if that answer makes sense. All right. Let's check it on the diagram if this answer makes sense. If going from R to B, it's saying go A and then go 4B, where 4B is a half of OK. So let's just kind of check it if it makes sense, right? So this is saying, let's draw it out in purple. This is basically saying, I'll leave those markings. I can put them back afterwards. This is basically saying to go from R to B, we're supposed to go 1A. A, remember, is A plus 4B, right? That's the answer. So we're going to go A from here. We're going to go 1A. This is the length of a A right here. So that could transfer in this length of a A up here. That's an A. All right, so this is an A right here. And then now half of a B. So this is a whole B right here. We don't want a whole B, we want half of it. So we're just estimating half of it will be about here. I'm marking out in purple. That will be half of a B. So if I were to move it up here, and you basically do this, just kind of sketch it out. You see, it is true. A plus 4B takes you from R to B. So you know it is correct. Now suppose you made a mistake, for example. That's why this check is important. Suppose you made a mistake, and for example, you put minus right here. And you had minus 4B instead. Right? For argument's sake. Then when you do your check, you would see that minus 4B, as minus 4B, you know, will be going in the opposite direction to this. We'll be going so. And then if you transfer this up here, they see that you're actually going in the opposite direction. You're actually going away from the B. So you know that you make a mistake. All right. So it's always good when you have your diagram to do that like a rough check. All right. It's a good practice to do. Kind of check to make sure that the answer that they get is correct. All right. I'm going to leave those markings on the screen. All right. Somebody wants the wages question. Which one is it? Which one is this? This one? Which one was the wages question? Number what is it?
Yes, sir. This one. I think it is possible.
This one right here? This one?
Yes, sir.
All right. This question says, Mika invests a certain amount of money in a bank that pays compound interest at a rate of 2.5% per annum. At the end of 2 years, the value of her investment is this. That's the total amount she has. Huh? Oh. You drop off. You better go find it. You don't know it then? I'm going to go bathroom and then I'm going to go bathroom. Something enough to do? It's not here. What am I to do? It's lost. Somebody lost it. Hold on, let me finish this. All right. So this is the value of the investment. So it's basically, and they give us a formula. It says the compound interest formula is this. And they're asking us to calculate the amount of our investment, right? So this formula is a matter of identifying from this information what they have given us and what are we trying to find. So let's look at it. And they kind of give us the formula down here and define the values for us. So A is the amount after n years. So A is really this, you know. So this is the value A, the amount in there, the value of the investment.
Sir.
So this is your A, yes?
And so the principal is supposed to be 7,564.50.
No. This is the amount in the account, the value of our investment. After 2 years, this is what is in there now. The principal is always what you start with, my boss. The principal amount is what you start with, not the amount that you have in there after 2 years. I'm going to look for the key? Yes. All right, thanks. All right, so that's the first thing. So this cannot be the principal amount because it says the amount, at the end of 2 years, the value is this. So this cannot be the principal. Principal is always the amount at the beginning. All right, so this is actually the amount. See, the amount, A, the total amount after n years. See, at the end of 2 years, meaning after 2 years. See that? After 2 years. This is the amount in there. So this is talking about the A. So that is the amount in there. So this figure is your A. This question is asking for the amount investment. This is asking for the P, the amount invested, the amount you invest. This question is asking you for the P. That's what this is, the amount you invest. That is asking for the P. This here is your R in the formula. This is the R in the formula. The R, the rate. See there? R is the rate per annum. The percentage on the rate is already taken care of by the 100 under here. So the R is just this value of 2.5. So the R is just this value, specific value of 2.5 without the percent. The percent in the formula is already taken care of with the 100 here. And then the time, N is the number of years, right? See there, N is the number of years. So this figure, this 2 right here is your N. Just put a different color to differentiate. This right here is your N. And the question is asking you for the P. It's asking us for that. So you're trying to find this. So all you have to do is plug in everything you know in this formula and then solve for the P. Only P you don't know. All right. So see here then, using this formula, let's do it in perf. Using this formula, I'm gonna just write it here. What we're gonna get. The amount is this. So I'm gonna write that $7,564.50 is equal to the principal that we don't know, that we're trying to find. So I put by the P times 1 plus the R is 2.5 up here. 2.5 divided by 100 raised to the power n. The n is this 2 right here. N equals 2. Easy as that. I'm trying to find P. So it's very simple. Let's take all of this thing here, so, and divide it under here, and you get the P. All right? Simple as that. So the P becomes equal to this amount, 7,564.50 over all of this. I don't even have to work it out. I'm going to put everything in the calculator. 1 plus 2.5 over 100 squared. I don't have to waste time on work it out. Therefore, the principal amount is, I'm going to put the dollar sign on it. Just work this out with the calculator now, we'll go. Just put it in the calculator exactly as it appears there. Now we get the answer. All right, so it is a fraction 7564.50 over bracket 1 plus a fraction 2.5 over 100 close bracket raised to the power 2. That's it. Let's put the square on this and no backspace. Let's put the square on this. See there? 7,200. So the principal is 7,200. That is the principal amount. See? Less than the amount after 2 years. That is it. Good with that, sir?
Yes, sir.
All
And
right.
if you get a chance, you can the factorization.
The factorization?
Yeah.
Huh? Which one? Like here? All right. So this is a common factor. Common factor is y. So we're going to factorize the y. We're going to get x minus y. This one is the difference of 2 squares. So it becomes equal to the difference of the 2 values, which is x minus y, and the sum of the 2 values, which is x plus y. And then down here now it says, hence solve this. So we're using these 2 results to solve this. So the numerator is what we had up here, which is y into x minus y, over the denominator is what we had here, which became that. So we're going to put that same factor under here, x minus y times x plus y, and then these cancel. So this cancels that. They're the same term, x minus y. So we're left with y over x plus y. So this becomes y over x plus y. All right, where you guys are now? $2024. So we're done with this paper. All right, 2024. All right, 2024.
2022. Me.
Somebody call 2024 first. Let's hold on.
Yeah, after that.
Yeah. Huh? Construction. This one. This one. All right. Let's see. All right, so let's do this construction. So the question basically wants us to construct triangle ABC. Would I give it AB already? You say AC is 8 centimeters, right? So you know C somewhere up here, right? And A to C is 8 centimeters. And B to C is 5 centimeters. So you need to construct this line. I also need to construct this line. It's quite simple. C is going to be on an arc. C is going to be on an arc that is 8 centimeters from here. 8 centimeters. And C is going to be on an arc. This is a different color. That is 5 centimeters from here. 5 centimeters from here. So all I have to do, draw an arc from here, 5 centimeters, and draw an arc from here, 8 centimeters. Where the 2 arcs meet, that's where C is. Simple as that. And they help you, they give you one line already. So they draw the line AB. So I'm just going to draw a random line here because I can't see what the length of that line is. So I'm just going to draw a line in here. So let's say that is the line AB that they gave us, right? This is A and this is B. And they want us to construct where point C is. So I have to use a ruler. So ruler here. I'm going to measure 8 centimeters. Because the question so I must use the compass to do it. Put me out to 8 centimeters here. Lock it. Move the ruler. Come to this end. All right. Position it up. Make an arc. So that arc, everywhere on that red line is 8 centimeters from A. Good? So then I need to come back. And then I need to measure now 5 centimeters with the ruler again. So we're going to adjust it. And measure 5 centimeters. I need an arc that is 5 centimeters. But there, let's change the color so we can see it different, right? So I'm doing that, I lock it. I'm doing that 5 centimeters from here now. So I'm going to rotate around and make an arc. That blue arc is 5 centimeters from B. So where the two arcs meet is where C is. Right? Because the red one is 8 from B, from A, and the blue one is 5. Sorry, the red one is 8 from A, and the blue one is 5 from B. So this point right here is where C is. And all I have to do is join it. There. And there. And you have your, let's do it again. That is it. And let's name this point C. And the question says, measure and state angle BAC. Now, BAC is this angle right here. BAC, right? So use a device, your protractor. Now, remember, you have to put the eye of the protractor on the point, not the base of the protractor, not the bottom of the protractor, like down here. Don't put the bottom of the protractor on it. The baseline must pass through 0. Okay, measuring from 0. Let me make it a little larger. So you make sure that your baseline pass through 0. See the 0 on the protractor there? The baseline that you're measuring from must pass through that 0 right there. And then make sure that you read also the 0 scale on the protractor. The protractor has 2 scales. On this one, the 0 scale is on the inner one. So measure on the inner one. And the outer scale is the 180 degrees going down from 180 down. So you really want to be measuring from the 0 up. That looks like on this diagram. Remember, we just draw the AB randomly. So that's not the same AB over here. But on this diagram, that would look like about 36 degrees. Right? Let me make it a little smaller, I might see it better. All right? See there? That's about 36, a little bit more than 36 degrees. Everybody can see that? Yeah. Good? Good. So,
Yes, sir.
Right. So I don't know what it is. I'm not going to put a measurement on this. I'm just going to write the word measure here. Well, at least you know how to measure. I'm going to write measure. You have to do it on the actual paper and measure this angle. That's what you're required to do. And state it. 1 E on this paper. All right. 1 E. 1 E. That's this one? No, it's a 2. 1 E is set. All right. That's down here. Can't do 1 E without the other part. I think you have to do the other part first. I don't think 1 E is in isolation. I can't just jump to 1 E because it relates to everything up here. So I don't know if I need information down here to do it. I don't know. Let me see. Let me see. I don't think so. But I think you need information from the first part for here. But let me see if that is the case. Let me just see if that is the case, right? Let's see. It said the cost for parking at the car park is shown in the table below. Let's see if it is an isolated question. I have related to above. It says under 30 minutes, you pay, it's free for park under 30 minutes. To park more than 30 minutes, but up to 20 hours, up to 2 hours, sorry.
Me,
yes?
Next, for the next one, can you do 2022 beans?
Yeah, we'll just finish this first now.
Oh,
all right, so yeah, so more than 30 minutes and less than 2 hours, this is a fee. All right, so they give you all these fees. So you're basically gonna look and see. It says, Michaela leaves the car park at 18:30 hours. You found it? And that's the key. See the key here, man. Jesus, see the key here. See the key right here, so don't lose it, you know. If you never lose my key, say beat, you know. If you ever lose my key, I beat, you know. I'm gonna choose my other key here. Huh? Don't lose it, you know. Right, so. Hold on a second, guys. I'm gonna just fix this.
My answer was 10:30.
10:30. All right, let's see. Trying to fix this key. Hold on a second. Almost done. All right, there you go. All right, guys. Sorry about that. All right. So Mika leaves the car park at 18:30. That's like 6:30 in the evening, right? And she pays this amount, $9.25. So she pays that amount. It means that she was operating in this time slot.
8 hours.
All right. He said determine the earliest time she could have arrived at the car park. So the earliest time she could have arrived at the car park must be now in sync with the longest time she spend there, don't it? And the longest time that she can spend there and pay this amount is what?
8 hours.
So she must have arrived at the longest time she could have arrived there to pay that amount. It's 8 hours before this time. 8 hours before that time is 10:30. So 10:30 is correct. All right? Make sense? So it has to be 18:30 hours minus the maximum time that I could have spent to spend that amount of money, 8 hours. So she must have arrived there. The earliest she could have arrived there and paid that amount is at 10:30 hours. Good. All right, easy. 1 mark for that. Right, so you want this part too? You don't want this part? It's just a part alone you want? Really? Yes? So, huh? Question 2C on this paper. Let's exhaust this paper and then the next paper going on through is 2022. That's this one right here?
Yeah, that one was complicated.
No, I don't think. All right, let's go. Somebody want this one as online as well. Let's do this one. It says the diagrams below show a triangle and a quadrilateral. All angles are in degrees and are written in terms of A and B. So these are the angles written in terms of A and B. What you know about a triangle is that the total of these angles must be 180 degrees because it is a triangle. So let's write that there. Because this is a quadrilateral, the total of these 4 angles must be 360 degrees. That's what is given. Once you get into angles, you know the total, what the total is. So the total of a quadrilateral is 360 degrees. All right, so you know that the total of these three angles is 180, and the total of these four angles is 360. The question said, for the triangle, show this. That's an equation relating to the angles, you know. The only thing you know is that the total is 180. So when you add up these and equate them to 180, it must give you back this equation. All right, let's write that. So for the triangle, the total angle equals 180. All right, I'm not going to put the degrees because I don't have the degrees here. All right, let's add up the angles now. So we can add up the like terms, you know. So this is A and a A in the angles. That make 2A right there. So, right? We're adding up these three angles, you know. We can just add up the like terms. So A and A is 2A. So I'm going to write 2A. Then the B is now 2B and 3B make 5B. 5B. So that's plus 5B. Plus 5B. And then the only number now in there is this 9 right here. And that will account for all the values in the angles. So I'm going to add plus 9. That is equal to 180. So if I take this 9 and subtract it over here now, 180 minus 9 is 171. So let's write that. Subtract 9 now. If I subtract the 9 from both sides, then I'm going to get that 2A plus 5B. This is going to be left. When the 9 gone over there to subtract equals 171. That was shown. All right, that's okay? Good. Then they're asking us for the same thing for the quadrilateral. So we're doing a similar thing for the quadrilateral now, eh? Total angle in the quadrilateral is now 360. So we're adding up all these four angles now, and they must be 360. Let's do a similar thing. We'll add up the A's first. So the A's first. 6A, 3A, that's 9A. 9A minus 2A, that's 7A. So that 6 and 3 is 9 minus 2 is 7A. So the A's add up to 7A. So that's 7A. Then let's add up the B's now. So the B's. Let's do the B's. So that is 2B and 3B and 3B. That's 8B right there, so 8B. The B's add up to 8. So I'm going to write plus 8B. Then the numbers now. The numbers in the angles. So the only numbers in the angles is this one. 18. So plus 18. And all of that add up to 360. I'm going to take the 18 and subtract over here. So let's write it over here again. We're going to subtract 18 on both sides. So this side is going to be left with this, which is 7A plus 8B. We'll subtract the 18 from this. We're going to get the 342. That also is shown. All right, nice and easy. Then it says, solve the pair of simultaneous equations to find the value for A and B. So basically, I want to solve these two equations simultaneously. All right, those are two linear equations. We can use our elimination method. All right, let's write it down and do them quick and fast. Nice and easy. The thing about it, they don't give a lot of space to work, but that's how it is. So we're solving, let's start over here, because we don't have a lot of space. 2A plus 5B. 2A plus 5B equals 171, and 7A plus 8B equals 342. Now remember doing this question. When I did this question last time, I eliminated the A. What I did, I multiplied this one by 7 to get the A to become 14A, and I multiplied this one by 2 to get the A to be 14A as well. This time, because I already do it that way, I'm going to now do it a way where I eliminate the B now. So let's do it another way. I'm going to now eliminate the B. So I'm looking for the lowest common multiple of the 8 and the 5. What is that? What's the lowest common multiple of 8 and 5? 40. Good. So I'm going to make the 2B values now come the same. Because I do it the other way where I eliminate the A's already. If you watch the video, you're going to see that way. I'm going to do it the other way this time. All right? So I'm going to multiply this equation because I want this to become a 40b. I'm going to multiply this one by 8. Remember, I have to multiply every value by 8. You know, multiply each term by 8. And I'm going to multiply this one by 5 to make this become 40. I'm going to multiply that equation by 5, the second one. Multiply it by 5. All right, let's get the calculator. So, okay, I multiply those big numbers there. 170 odd and stuff. All right, let's go. All right, so multiplying the first equation by 8. All right. So the 8 times this 2a give me 16a. 8 to is 16, so I get 16a. The 8 times this 5 give me the 40 that I want, so I get plus 40b. All right, the pen not so nice and neat. I need to multiply this side now by 8 as well, right? So I'm going to do 171 times 8. 1368. So I'm going to get this being equal to 1368. All right. Then I need to multiply this equation now by 5, right? So let's go. Oh, I need a blue. So I multiply this by the 5, 7, 5, 35. So I'm getting 35a. Multiply this by the 5, I get the 40 that I want. 40b equals, multiply this now by 5. Let's see. So it's 342 times 5. 1710. 1710. 1710. So because these two b values are the same sign, to eliminate them, I have to subtract the two equations. I have to subtract the two equations. So let me take everything on this side. Yes. So I'm going to subtract. So I'm going to use the larger one minus the smaller one. But I'm going to say I'm going to subtract. If you want, you can call them equation 1 and 2. Also, but I would normally just write subtract here, because it doesn't really matter. So I'm going to say, okay, I'm going to subtract the two equations. Subtract. And I know I'm doing the larger one minus the smaller one. So firstly, it is this 35 minus this 16a. So 35 minus 16, that give me 19. So I'm having 19a. This 40b minus this 40b, the b gone, equals this now minus this. 1710, 1710 minus, what is that? 1368. I get 342. 342. Then to get the a now, I just need to divide both sides by 19. Or shortcut, we said the 19 over here is multiplying. We just divide it on the side. Anyway, take it. The a is going to be equal to 342 over 19. Let's work that out. 342 over 19. So it's 342 divided by 19, 18. So that is 18. Then to find the b now, I just need to take this a value and substitute it for the a in one of these two equations. And that one or this one. Any one of them. And work out the a, work out the b. Let's say I'm going to put it in the first one. So I'm just, because they don't give us a lot of space, I'm just going to come and say and. I'm just going to say and. I'm going to do the substitution. I'm just going to say and. I'm going to take the 18 and substitute it right here. For the a in the first one, it's going to be 2 times 8, 2 times 18, sorry, plus 5b equals 171. To get the b now, guys, let's do a one step. I'm going to take the 2 times 18 and subtract it over here. And then take this 5 and divide it under. All right, you subtract and then divide. So, because I don't give a lot of space to work. All right, let's move this up a little bit and change the color. So let's make the distinction. All right, let's just change the color. I don't give a lot of space to work. Let's just move it up a little bit. Let's draw a little box around this. Just okay, we finished this part already. I want to working out the b, right? So I'm going to subtract this and then divide the b, divide the 5. So the b is going to be 171 minus 2 times the 18. So I write 36 That's fine. Divided by 5. And just put that in the calculator and we'll get the B. So it's a fraction 171 minus 2 times 18 over 5, 27. So the B equals 27. Then I was going to indicate that this is an answer and this is an answer. That is it. Somebody asking for the circuit theory on this paper. Yeah. Huh? Like the whole paper no want me do. Eh? The whole paper no want me understand. All right, circuit theory. Circuit theory.
No, you're skipping too far. Like go. I mean, the one with the
What number?
with the what do you call it? The diagram.
This
Not
one?
the reflection one.
Or the transformation?
No,
You
that
want
one.
This one?
Statistics, yeah.
Oh, so it's a reflection one. Or the statistics. Let me see if the reflection one on this. Transformation. You don't want this one?
Yeah.
You want that one as well?
Mm.
All right. Let's do this one. Then we're going to do the statistics. Then we're going to do the circuit theory. Somebody also wants the bearings. More maths equal better maths. Let's do it.
It's
Come
not
on.
I and I too. It's like it's the.
It's not
It's
what?
not that. It's not that part of C. It's
You don't want this?
No, I want this. It's just yeah. No, never mind.
No, I have to say which question you want to do.
It's that
You
one.
don't? Huh? This one
It's
right
that
here?
one. No, no.
This one?
Yes.
All right, let's do this one. Argument done. Let's do this one. Question says, the diagram below shows 3 triangles, P, Q, and R. It says Q and R are the images of P under a double transformation. So, like we start with P, and we go to Q, and we go to R. Or maybe the other way. Start with P, go to R, and then go to P. No matter, let's follow the instructions. Question says, describe fully the single transformation. Say keyword single. Single transformation which maps P onto R. So see, they went to R first. So from this one up to this one. Let's look at them carefully. So look at those 2 triangles. They are exactly the same. Just that they are in a different position. So the transformation that keeps everything the same, but just puts it in a different position, is translation. So like this one just moved up to here. Or we could say this point moved to here. So to determine the translation, you need to know how many units left, right or left, and how many units up or down. And you just need to see what happened to one point. So I'm going to use this point as a reference point to see how I went from this point to this point. So you need to count out the horizontal movement first. In this case, horizontal movement is 2 to the right. That is it. So 2 to the right. And then you count how many upward it went. So this is 4 upwards. So it went 4 upwards this way. So this is 2, 4. So it's a translation. Translation 2, 4. We'll have to go and describe it properly, right? So when it's a translation, so translation, transformation 2, 4. You can actually see this out. 2 units to the right, 4 units upwards. Remember, if there were a case where the thing went to the left, this would have been negative. the case where the thing went downwards, this y value would have been negative. So the first value here is a horizontal movement. Remember, this way is positive and this way is negative. And then this value here is always the vertical movement. Down is negative and up is positive. But this time is up. That's why that is a positive. All right. So I'm going to go and describe it as a translation. 2 units to the right, 4 units upwards. That's P to R. All right. So it's going to write that here. It's a translation. 2 units to the right, 4 units upwards. So a translation. I have to give the name of the transformation. A translation is the name of it. Translation. 2 units to the right, or you could say 2 units in the positive x direction as well, right? And 4 units upwards. Or instead of 4 units upwards, you could have said 4 units in the positive y direction. And we could also add the matrix and say given by. I think if you write just this, you give it the marks, but you can add to it and say given by the matrix 2, 4. All right, but I'm sure if you just left them with this, you'll give it the marks. All right, I say it's a translation, I give the components. The next part wants us to transformation now from R to Q. So from R to Q. That's now from this one to this one. So let's look at it now. So this is a reflection. One is a reflection. First, I can see the orientation is reversed. So let's name a couple points. So this point is A. Let's up here so it's B. And let's right here so it's C. Let's give it some name so we can reference it. The point corresponding to this one is over here. So this would have been A prime. The point corresponding to this one is here. Stop it talking now. Stop it talking. Stop it talking. Hey, tell me to stop it talking now. This point corresponds to this one. So this point would have been B prime if they are those. So the orientation of this one, if you look at it, A to B to C is this way. That's anti-clockwise. And this image, A to B to C is the other way, clockwise. So when the orientation is reversed, we know we have a reflection. Why am I saying that? Oftentimes, a reflection and a rotation can look alike. You can see a reflection and believe it's a rotation. To make the distinction, all you need to do is check the orientation. If the orientation is reversed, you know you have a reflection in a line. So that's how I would check this. And so I can confirm it is a reflection. And a reflection is a mirror line. All I need to do is state that it's a reflection, but you also have to state the mirror line. You cannot describe a reflection without stating the mirror line. The mirror line is going to be halfway between the corresponding points. So these 2 points correspond. Halfway between them is right here. Again, these 2 points correspond. That same blue line is halfway between them. So this line is our mirror line. You have to give the equation of it. Now, that's a vertical line. Vertical lines carry an equation, x equals a number, just like the y-axis. The y-axis, remember, is x equals 0. So lines vertical like the y-axis will carry that number, that equation, that form of an equation, x equals a number. It passes through 1 down here. See, passes through 1 down here. And so it is x equals 1. That's a mirror line, x equals 1. All right, so the equation is reflection in the line x equals 1. Mute your mic, please. So this one is a reflection in the line x equals 1. All right. When you describe a reflection, you give the equation of the line. If you describe an enlargement, you have to give the scale factor and the center of the enlargement. If you describe a rotation, you have to give the angle of the rotation, the direction of the rotation, and the center of the rotation. All right. I'm just saying that, even though those were not on this question. All right. The next question somebody wanted as well. No, I think there was a question before. Somebody wanted the statistics right here. So we're going to run through the statistics. All right. Question says, the mass M in kilograms of 120 newborns. 120. So we know that this total down here is 120. 120 is the total down here. All right. In a hospital are recorded. So these are the mass of the babies, the newborns. That's the number of newborns. So 7 newborns measure between 2.6 and less than or equal to 3.5. So these are your upper boundaries and these are your lower boundaries. All right. It says, what is the modal class? The modal class is the one with the highest frequency, the one that appears the most. That's the highest frequency. Therefore, this is the modal class, one with the highest frequency. All right, the one that appeared the most. So this class appeared the most times. There are more babies in this class more than any other class. So that's the modal class. So it's going to be the 4.4 less than M less than or equal to 5.3. Make sure you put on the kilograms, because the classes are in kilograms. All right, that is it. Next part says, complete the table below and calculate an estimate of the mean mass of the 120 newborns. All right, so they want us to complete the table. So this column is a midpoint column, and they want us to complete this FX column. This FX column is what we call our sum column. So we have summing the mass, in this case, of the newborns in the group. So, and the midpoint is basically used to represent the group. And why is this an estimate? Why is this an estimated mean? Because we don't know the actual mass of the newborns, the 7 newborns in this group. We don't know the actual mass of those 7 newborns. We have to make an assumption for the purpose of estimating the mean. And the assumption is that all 7 of them measure 3.05, which is the midpoint of this group. All right? And the same thing applies to all the groups. And that's why this is an estimate. And 6 will ask you that. Why is this an estimated mean and not the true mean? Because you don't know the actual mass of the newborns in the groups. So you use the midpoint mass to represent the group. And maybe none of the babies now actually measure 3.05. Maybe none of them don't measure 3.05. We have to make that assumption, all right, for the purpose of estimating. So if you notice, however, these lower limit values, lower boundary values, sorry, they're going up by 0.9. I can see it in the because this one to this one is go up by 0.9. These upper values, boundary values, also increasing by 0.9. The midpoint values will therefore also increase by 0.9. So you don't have to waste time and actually calculate the midpoint. And the midpoint would have been the average of these 2 values, but you don't have to actually calculate it. You just need to add 0.9 to this to get the next one, and add 0.9 to this to get the next one. That's all we have to do it quickly. All right. So there were more some friendly numbers. Let me just get the calculator and work it out. It's supposed to be so it will be 4.85 plus 0.9, 5.75. So this is 5.75. And then 0.9 plus this one. That one plus 0.9 again, which is 6.65 plus 0.9, 7.55. All right. And then now, to complete this row, we need to multiply. So you multiply the frequency by the midpoint value to get these. So you need to multiply these 2 to get that. So it's 29 times that. So it's 29 times 5.75. 166.75. 166.75. And then we also multiply these two to get this value out here. So it is 7.55 times 8. And that gives us 60.4. So all of this now basically represents total, an estimate of the total mass of the 120 newborns. That's what this is, a quick calculation for the total mass of the 120 newborns. That's what the sum of fx is. So here we're going to calculate the sum. This means sum of the sum of the sum column, and work it out. We're adding these up. That represents the sum. But this figure is just the sum of the 7 newborns in here now. And this one is the sum of the mass of the 80 newborns in here. And so to get the sum of all 120, we just need to add up these. That's an estimated value. So let's add up these now. So it's 21.35 plus 71.1 plus 145.5 plus 166.75 plus 186.2 plus 60.4. Just checking to make sure we add up now properly. Just making sure we have the right figures in there. Sometimes the finger can press the wrong button on the calculator. And so this is giving me 651.3 kilograms is the mass of all the babies. How many babies there are there? The sum of the frequency, which is 120. All right, so we need these two figures now for the mean. So this is the mass of all 120 newborns combined, approximately. There are 120 newborns, so the mean is the total divided by the number of newborns. Simple as that. It's not just a formula. It makes sense. It must make sense. So the mean mass of a newborn, the mean, is equal to, and the symbol for the mean is x bar. Let's write it. X bar is equal to the sum of the sum column divided by the sum of your frequency. Sum of frequency is the number of newborns. So put in this figure, 651.3 over 120. That gives you the average mass of a newborn. So it's 651.3 divided by 120. 5.43. Put it to three significant figures. 5.43. I must give the unit of the data, which is kilograms. All right, don't just put 5.43. It's actually a unit of the data, 5.43 kilograms. Make sure you put the kilograms. All right, so far so good. Let's continue. Down here now says, one newborn is chosen at random from the hospital. That's one out of the 120, right? Find the probability that the newborn has a mass greater than 5.3. You want the mass to be greater. You want the mass to be greater than 5.3. So we need to know how many babies or how many newborns had a mass that was greater than 5.3 and divide that by the 120 to get the probability. So let's see how many of them greater than 5.3. So look in the table for the 5.3. So this is where it is less than 5.3. You don't want less. One greater. Right here starts the ones that are greater than 5.3. Right? So if you read it from right to left, that's what it is saying. That is the same as saying that the mass is greater than 5.3. And it is forever greater than 5.3 up here. So all of these, mass greater than 5.3. These are the babies whose mass was greater than 5.3. So you need the sum of those. Don't put this in a different color so we can relate it. Let me just put this in a color. So all of this related. Let's put this in purple or so. I think I'm going to have to come back anyway. Let's put this in a color. Just to show the relationship. Put it in green. No, I don't change. Good. And then this now is all the baby, all of the greater and 5.3 mass, all of these, which will be all of these right here. I'll just basically add up these and put it over the 120. All right, what that add up to? Let's try to add up to from now. So it's 29 plus 28 plus 8 plus 8. 65 of them, right? 29, 28, and 8. Let's do it down here so now. Let's do it down here. So the probability that the mass is greater than 5.3 kilograms becomes equal to, let's show the work, 29 plus 28 plus 8 as a total over the 120. And then we can just work it out and put it as a single fraction. So we know 65 over the 120. And as a simple fraction, it is this. 13 over 24. Your calculator should be able to give you that. That reduces to 13 over 24 when you simplify it. All right, good. Next part now says, it says complete the cumulative frequency table below. Complete the cumulative frequency table shown below. Now, remember, cumulative frequency table really is a counting table. It's really a counting table. That's what it is. That's what cumulative frequency really is. It is counting how many babies are less than or equal to the masses over here. Counting up the babies. How many babies less than 3.5? Less than or equal to 3.5. 7 of them.
Yeah, how many babies?
Huh?
Yeah, I get that part. That's the easy part.
So that's easy.
Add 55 and plus the Q.
Yeah, I know a lot of people know to do it, but I don't really know what really happened. But anyway, all right. So you don't want an explanation. No problem. I like to explain, but all right. So basically add up the values, right? What are the values to add on? Let's see what are the values to add on. We're adding on, they gave us up to 5.3. So we need to add on these. Oh, these are on these same three figures here, right? 29, 28, and 8. 29, 28, and 8. So here we're adding on 29 to this one. So this is 55 so far. Plus the 29 more in this group. So you reach, how many babies you reach? Now you reach 55 plus 29, reach 85 babies, newborns. So far, then you're adding on the number in this group, which is this 28, 28 more. So 84, and you add on 28 more to get a total that is less than 7.1. So add on 28, and be 1, 1, 2. And you just add on the 1, 1, 2 to the 8, and we'll get a total 120 newborns, less than that. So there's a figure that we need to add on to this data, which is the value that would have come before this one, which is 2.6. If you subtract 0.9 from that, you're going to get 2.6. So the mass, for mass, less than or equal to 2.6. That's 0 babies. And this needs to be shown on the cumulative frequency curve as well. All right. You need to show that on the cumulative frequency curve and see if you can actually ask a question about that. And what it means is that no baby had a mass that was less than or equal to 2.6. No baby had a mass less than or equal to 2.6 grams. Why? Remember, the table started at greater than 2.6 there. Started at greater than 2.6. So no baby, no newborn measured less than or equal to 2.6. That's what this means, and it must be represented on a cumulative frequency. So I normally add this on, right, as data. Then down here, I want us to basically complete the graph. All right, so first thing you want to do is check the scale, make sure the scale is correct. So on the x-axis, check the scale is actually 1. These 10 lines accumulate account for 1. So each line is 1 over 10 or 0.1. So we therefore know that, for example, this is 2.6, 2.7, 2.8, 2.9. This is 3, 3.1, 3.2, 3.3, 3.4, 3.5. Always check the scale. Make sure you understand the scale. Up here, is 10 babies. Remember, these are the babies now. These are the 120 babies, you know, in ascending order. So the lighter babies are down here, and the heavier babies are at the top. We need to recognize that that's what it is. The babies are in ascending order of their weight. The lighter ones are down here, the heavier ones are up here, corresponding to the heavier weight up here. All right, we need to understand that about a cumulative frequency curve. And so, want to know what each line is. So it's 10 babies divided by 5 lines. So each of these lines represent 2 babies, right? Let's make sure 2, 4, 6, 8, 10. You have to always establish that before you start to read a graph. This point is not correct. We did say 0 babies is less than or equal to 2.6. So this point really should have been here. This is not a correct point. That's where it's supposed to start. Here, less than or equal to 2.6 babies, 0. All right. And then we want to check these other ones as well. 3.5, less than or equal to 3.5. Oh, next thing. This graph is a less than or equal to graph. It's not just a mass graph. It is actually a less than or equal to mass graph. So it shows how many babies measure less than or equal to a given mass. Why am I saying that? Because it was less than or equal to mass data that was used to give it a cumulative frequency values. So this is a graph showing how many babies measure less than or equal to a given mass. Why is it necessary to show that? Because you don't know the actual mass of the babies. You only know how many babies measure less than or equal to the upper boundary value mass. You don't know the actual mass of the babies, right? So that's all you can do on a cumulative frequency graph, because you don't know the actual mass of the babies. Anyway, so less than or equal to 3.5, 7 babies. 7. Let's check it. 7. Teacher now. 2, 4, 6. 7 is right here. This point is wrong. All right. So the correct point for that one is here. These things happen in CXC, guys.
To repeat.
This point is wrong. This is 5. Look at it. This point is on the 5 mark. 5 babies. Our table has 7. 7. Less than or equal to 3.5. 7. That point is wrong. It's in the wrong place. If you find the error, correct it. Nothing wrong with that. It's human beings at the paper, they make mistakes too. So it's not 5, it's 7. So this point is at 5, it should not be there, it should be at 7. 2, 4, 6, 8. Here is 7. So it really should be here. All right, that's where you're supposed to be. Right here. So this X should be here. So I'm going to ignore that one. Let's check if this one is correct. 4.5, let's go 4.5. This looks like 25, right in the middle there, 25. 4. It's actually 4.4, 4.4, 25, 4.4, 25. Yes, 4.4, 25. Then 5.3, 55. 5.3, 55. So they didn't give us that one, so I have to put it on. 5.3, 55. Where's 55? 55 is right between the 50 and the 60, right between here. And this is our 5.5 line. It's 5.5, yes, right here. So coming right to this point right here. Right here is the next point. All right, so let's just check those. Next one. This one is no, not 5.5, 5.3, 55, 5.3. So I still put the wrong place. So actually here's 5.3. This is 5.5, 5.4, 5.3 is here. So this is where I need to be here. 5.3. All right, 5.3 is this line. Mark it properly, Mr. Shaw. 5.3 is this line, 5.3. All right, and it's at 55. 55 babies. Measure less than or equal to 5.3. All right, next one. All right, let's just copy them down. Let's write them out and copy them down. All right, so we have 6.2, 84. Then we have that 6.2, 84. Then we have 7.1, 112. That's the next point. Then we have 8, 120. 8,120. 8.0120. All right, so these are the 3 points that we need to put on there. So let's copy that down so that we're going back and forth. All right, let's put it down here. All right, so we're looking for 6.284 now, 6.2. So this is 6 right here. Halfway between 5.5 and 6.5 is 6. This is 6. 6.2 is this line. This is 6.2. All right, so that line is 6.2 right up here. We're trying to go all the way up to 84. Where's 84? So this is 80, 82, 84. This is the 84 line. 84. And we're coming up on the 6.2 line right here. So we're talking about this point where those meet. That's what we're looking at. So you could just actually look at it on the exam paper. This is 8.4. 84, sorry. So that is that point. The next one is 7.1112. So let's mark the 112 first. So this is 110. This is 112. 12, 14, 16, 18, 20, right? So this is 112 line, this line right here, right above the 110. So we're going to be on this line right here. And we're looking for 7.1. 7.1. 7.1. So this is 7. Right here is 7. So this is 7.1. So open up on this line. 7.1 is this. So coming to this point. That's our next point. Right there. And then 8, 120. So this is our 8 line right here. This line is our 8 line. 120 is right on the top line there. So it means that we're coming up here. Right on top. Alright, so those are our points. Draw the smooth curve through those points. Let me just brighten up these. Alright, this one, as I said, is wrong. So I'm going to leave it out, and this one is wrong. Alright, so I'm going to draw a smooth curve through those points. Let's draw it in blue. O give must have that characteristic shape. Alright. I think you can draw it so smoothly, guys, so bear with me. That is it. I'm going to work with that.
So I can go back to the first table, please.
The first table.
Yeah.
For the top. This one.
Yeah. Not this one. Just both of them. Not only this one.
This one.
Yes, sir.
And next one too.
Yeah.
All right.
Yeah, that's better.
What I want us to do anything, it says use the graph to estimate the median. So median is the weight of the 60th baby. It's an estimate. Some people say you must go to the half of the n+1 term, but when is group data like this, you're estimating, it's okay to go for the weight of the 60th baby. So the position of the median baby is the 60th baby since they were 120, the baby in the middle. Remember, these are the babies, are the newborns in ascending order of their weight. You want the one in the middle. The one in the middle is approximately the 60th one right here. Half of 120. That is the position of Q2. Q2 is a symbol, it's the second quarter symbol for the median. So you come across on the graph and read it down. Until last time I did it, I got exactly this value. All right, but I'm going to work with what I get this time. No problem with that. The last time I did it, You know, not everybody gonna get the same exact same answer. Not everybody gonna draw that curve exactly the same way. So just give the answer based on what you got. Wobble it to the board. So today I'm getting it right in between. You look at the video, I got it on this line. But today I'm getting it here, no problem. It's an estimate. So but the answer is going to be different based on how you draw your curve. And whichever answer you get, whichever answer your curve give you, CXC will give you your marks. You have to draw it with a straight line, guys. Don't draw a wibbly wobbly like me. I just have a device. This device don't allow me to draw it straight. So the right here, remember, is 4.4. So in between here is 4.45. In between 4.4 and 4.5 is this 4.45. That value there, that is my Q2 value. Q2. Based on that mark right there. All right, so we're gonna write median Q2 is 4.45 kilograms today. Look at the video, you're gonna say 4.5, but you will see also why I put 4.5 for this question. That is that. All right, somebody wanted the what?
The 2022.
No, man, I just want to exhaust this paper and then I go to the 2022.
Oh,
so somebody wanted something else.
Circle theory.
Somebody wanted the circuit theory.
Right.
Somebody wanted circuit theory. Circuit theory right here. All right, so to do circuit theory questions, guys, remember you have to know the rules. You have to know the rules. I'm not gonna go through the rules now. There are videos there with the rules. You have to know the rules. All right. I did a marathon where I did circuit theory and explain how you know which rule to use and stuff. So you can find that video on the channel and look at it. And you see the chain of thought or the process that you can use to see which rule you need to use to find an angle. All right. Let's look at this one now. It says K, L, M, and N are points on the circumference of a circle center O. It says XY is a tangent. So this is a tangent right here. At the point K is a point of tangency. Then it says angle LKY is 48 degrees. That's out here. That's clearly an angle between a tangent and a chord. All right. So that will have to be used. And angle MKO is 12 degrees inside here. This angle right here is 12 degrees. All right. They're giving us that angle as well. And then angle XKN is 56 degrees. That again is an angle between a tangent and a chord. That's 56 degrees. So again, this angle is going to automatically be 56 as well. But let's continue. We'll get into that. First question says, find the value of angle KOL, given reasons for each step in the answer. That's this angle inside here. All right. So let me give you a process that we could use. All right, and this is an angle at a center. Note it's an angle at a center. So center rule will come into play. Center rule can come into play, don't must, but can come into play. All right. Also, it's an angle in this triangle. That triangle is an isosceles triangle. So there's not one way to do the question, multiple ways to do the question. All right. So let me use the fact that it is isosceles first. Let me use one method first. I'm going to show you more than one method and maybe just write one on the paper, right? All right, so the first thing, I recognize that this is a radius and this is a tangent. So the angle right here says 90 degrees. So if that angle is 90 degrees and this piece of it is 48, then inside the triangle here, remember now the whole thing is 90. This piece is 48. So the remaining piece inside here has to be 42. Why is that 42? 90 degrees minus 48 degrees, that is 42 degrees. Now this thing is an isosceles triangle. This triangle inside here is isosceles. Why is it isosceles? Because this line is a radius and this line is a radius. They are equal. And so since those two lines are equal, these two angles are equal, these two. And so if this angle is 42, then this angle also is 42. So we can put a 42 on this. So this is 42 degrees, And this is 42 degrees. Yes? Huh? You sure so what? This is 30, my boss. That's a 30. All right, so it's a 42. And then if you know two angles in a triangle, you can find the third one. So this angle up here that I want is going to be 360 degrees, not 360, sorry, 180 degrees a triangle. 180 degrees minus 2 times 42. All right, it's going to work out to 96, right? Okay, subtracting 84. That's one way to get the angle is 96. Let's look at another way. More maths equals better maths. All right, let's look at another way. All right, look about the process of elimination now. Look at this process now. So the question asks us for this angle. Let's say, so okay, that's for that angle. I always say, find the chord or the arc that is subtending the angle and look what else the chord is doing. Or what else the arc is doing. Most times it's better when it's a chord that is subtending the angle. And that's what we have here. How do you find the chord? You come back along the sides of the angle until you reach a circumference, which is here. And you come back along the other side until you reach the circumference. You don't stop there now. You come all the way back until you reach the circumference, which is here. So what is the object? What is the chord subtending that angle? I'm going to draw it in red. This is a chord that is subtending that angle. That chord. What else is that chord doing? It is glaringly making this 48 degrees with the tangent. Good? So that red chord is making an angle of 48 degrees with the tangent. So since this is making an angle of 48 degrees with the tangent, that same chord is going to subtend that same 48 degrees at the circumference. We call it the alternate segment rule. Angle between a tangent and a chord is equal to the angle subtended by the chord at the circumference in the alternate segment of the circle. So it means that this same chord is subtending this angle at the circumference up here. So this angle up here is also 48 degrees. This angle is 48 degrees. Now why am I getting that one? Because now this chord that is subtending this angle at the circumference, 48, it is the same chord that is subtending this angle at the center. And that one at the center must be twice. The center rule says angle at center is twice the angle subtended at the circumference when they are subtended by the same chord. Angle at center is twice. So because this is 48, then this angle in here that we want is 2 times 48 degrees, which is the same 96. But we could merge those two together. We could merge those two rules together. That angle between a tangent and a chord equals the angle subtended by the chord at the circumference, and that the angle at the center is twice the angle at the circumference. So if the angle at the center is twice the angle at the circumference, and the angle at the circumference is the angle between the tangent and the chord, then it means that the angle at the circumference is twice the angle between the tangent and the chord. Make sense? Or merge them. So it means then, if we take back this out, then we can extend those two rules and say, okay, because this angle that we want here is subtended by this red chord, and that red chord is making an angle of 48 degrees with this tangent out here, then the angle at the center is twice this one, because we merge the two of them. So the angle at the center of a circle is twice the angle between a tangent and a chord becomes half the angle at the center. And the angle at the center is twice the angle between a tangent and a chord. So we can simplify and put that as a rule. Right? So the angle that we want, angle KOL equals 2 times 48 degrees, which is 96 degrees. And I'm going to give a merge rule. I'm going to merge the two rules in one and say, what is the reason? Angle between tangent and chord. That's right here. Angle between the tangent and the chord is half the angle at the center. Subtended, which is subtended by that chord, or by the chord, one chord we're talking about. So merge the two of them in one. If you want to go the triangle route we said before and do it, fine. But I like to just write one reason rather than combine three different reasons to get the one answer. You understand me? So I'll go that way and put everything in one. All right, so that's the first thing. Angle there is 96 degrees. So let's put it on the diagram. So this angle inside here says 96 degrees. We have found a number of angles so far, if you notice, right? We have actually found a number of angles so far. So this angle is 96. All right, what other angle do I want us to find? So see, this one asks for reasons, guys. What I find these days is that they're asking you, but I want you to find multiple angles. What I find that they're doing these days, they ask for one angle with a reason, then they ask for 5 different angles. You don't need no reason, just calculate. That's what I found that they've been doing recently. Because instead of asking you 2 questions or 3 questions with reasons, 3 angles with reasons, they tend to give you just 1 angle with reason or 2 angles with reasons. And then they give you 4 or 5 angles. Just calculate them. You don't need to write the reasons. But you have to have the reasons in the head. So you have to get them on based on the reasons, right? So anyway, let's continue. So that's the reason one. Look here now. See down here now, they don't ask for the part 2 now, but they don't ask you to write no reason. They just want to calculate them. Find the value of each of the following angles. You don't need to put no reason. And it's 1 mark. You see it? So that's what I'm talking about. This is 2 marks. Maybe 1 for the angle and 1 for the reason. All right? So down here, our first angle I want is LMN. Let's go up and see what LMN is. Which angle is LMN? LMN. All right, so I want this angle up here, LMN. LMN. So because I looked at the diagram when I was reading out the angle, I recognize that because this angle is 38, subtended by this chord, the chord is going to subtend is 48. The chord is going to subtend the same 48 up here. So this angle right here says 48. And then now I also showed you that angle between angle subtended by this chord right here and the tangent, between the tangent and the chord is 56. And that this chord is going to subtend 56 at the circumference here. So that total angle that I want, that blue angle that I want, is the sum of those two. See it? 56 plus 48. But I said that tangent and chord rule on this side, give you 48 here. Tangent and chord rule on this side, give you 56. The total is 56 plus 48. But I said that 56 plus 48. I'm going to write that down here. 56 plus 48. You get another way, that's fine.
All so that for 2 marks?
Huh? It's 1 mark.
All of that for 1 mark?
It's 1 mark for everybody, mom. Everybody getting the same 1 mark, so don't worry about that. It's not one mark for you and 2 marks for somebody else. It's 1 mark for everybody.
All that work not for one for
no, this is not a lot of work. This is not a lot of work. You're adding 2 numbers. You're adding 2 numbers. You have to know the rules. As soon as you look at this diagram, if you know the rule, look. If you know the rule, as soon as you look at this diagram and see this angle right here, so between this chord and this tangent, you should know that this angle is the same, 48. That is just no, that is not work. And as soon as you see over here, this angle between this tangent and this chord, you should automatically know that this angle here is 56. And the question is now asking you simply to add up those two. They're not asking nothing magical. They're asking you to add 2 numbers for 1 mark. That is all. I don't think that is unreasonable. They're asking you to add 2 numbers that you should know by just looking at the diagram for 1 mark. That's not difficult. You have to know the rules.
Yeah.
All right? You have to know the rules. As soon as you see the angle between a tangent and a chord, you know so the chord subtend that same angle. As soon as you see the angle between this tangent and this chord, you know that the chord subtend that same angle. So as soon as you start to read the question up here, and you're identifying the angles, you should start to see other angles spinning off from what they are showing you. You should see it right away. The way to see those things quickly and immediately is to know the rules. You have to know the rules. It's not an unreasonable question, believe me. So they're asking you to add 2 numbers for 1 mark. That's not unreasonable. That's not a lot of work. That's 56 plus 48. We're adding them. This equals 56 degrees on one side plus 48 degrees on the other side. How much I work out to? 104. 104. Make sure. 56 plus 48. My brain is tired. 104. Next angle I want is angle KLO. Let's see where that is. KLO. Let me erase these. So I'm leaving these 2 as added up together to get that 56. KLO. Where is that now? KLO. KLO. Well, that one easy because this now coming inside this triangle. See? KLO. This angle. This is isosceles. Once you know one angle in an isosceles triangle, you are blessed. This angle here, since it's equal to this one, we know already it's 42. All right? It's 42. You can use a triangle to do it, show that it's 42, or you can say it's a 90 degree that is here. That makes this one 42, and this one is equal to it. So that's 42. But if one is a triangle approach, we could say that that angle is 180 degrees minus the 96 degrees divided by 2. It's going to work out to be 42 degrees. Total angle in the isosceles triangle is 42 degrees. So I might write this one there. 180 minus 96 over 2. So this will be equal to 180 degrees minus 96 divided by 2. It's never one way to get the answers, guys. These things, if I do this another day, I get the answers different ways. If I do it 5 days, 5 different ways, I get the same answers. All right, 42 degrees. Then I want angle MLK. Where is that? Angle MLK. Let's see the one that we'll find on the diagram. So we now know that this is, we know that this is 42 degrees. I leave that out. 42 degrees. Keep erasing the wrong thing. All right, that's 42 as well, right? Which angle I asked us a while ago? MLK. 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 That's this angle you don't want now. Multiple ways to do it as well. But I would say I could maybe look at this red triangle now. Because I have this 48 degrees in it already. I know that this blue angle here is 42. And this piece of that blue angle is 12. So inside this triangle right here, I'm going to mark in red. This has to be 30. This has to be 30 degrees. This has to be 30 degrees. And they're asking us for this. They're asking us for this over here. So that has to be 180 minus the 30 and the 48. All right? So that becomes 180 degrees minus the 30 and the 48. Our total angle in the triangle is 180. So you minus, you're subtracting 78. That's 104 as well. No. 180 minus the third minus 78. 102. Yeah, 102. 102 degrees. So I'm going to put this as my calculation and leave them on the diagram. Leave the diagram mark up like that, you know. So examine and see where I got my values from. All right. So I'm going to put 180 degrees minus 30 degrees 148 degrees in bracket. That is 102 degrees. All right, then I want angle KNM. Angle KNM. Let's look at it now. KNM. Hey, tell them about this going for me now. KNM is this angle right here. Let's look at a nice way to find this angle. KNM. Let's find a nice way to find this angle. So look at this angle now. Don't want this angle, right? Watch this now.
Sure, is it 56?
This?
Okay.
Nope. This angle here, sir?
Yeah.
Nope. That's not 56. Let me show you a nice way to find this angle. Firstly, you could use a cyclic quadrilateral here, right? That's a cyclic quadrilateral. 4 vertices on a circumference, it is cyclic. So it means that these two angles opposite each other. Mark a different color so you can see it, green. These two angles opposite each other, they add up to 180 degrees. The one is 102, so inside there's 180 degrees minus 102 degrees, which then is 78 degrees. That's one way to get it. Maybe that's the easiest way to get it. All right? So that will be the answer right there. 108, 180 minus 102, because opposite angles in a cyclic quadrilateral add to 180 degrees. Fancy word for that is that they are supplementary. But let me show you a nice other way to do it though. More maths equals better maths. So a nice other way to do it is to recognize, watch this now. I'm going to draw it out in purple. Now this angle that we want up here is subtended by this chord. Because you see, if I come back along the sides, making the angle, the circle, I'm going to get this chord. Watch this now. See that chord, that purple chord that was draw, that is subtending that angle. It is making this angle with this tangent out here. Got it now. This whole angle with the tangent. That whole angle is 30 plus 48. So this angle is 78 degrees. So it means that the chord subtends the same angle of 78 degrees at the circumference. You have to know that rule and get comfortable with it. So that's another way you could get the 78 degrees. Angle between tangent and chord. All right? So it can be the 180 minus 102, or it can be the sum of the angle between the tangent, the 30, and the 48. Well, let's put the 102 minus 180 down here. I think that's what most persons would do. 180 degrees minus 102 degrees for the cyclic quadrilateral. That is 78 degrees. Or it could be the tangent and chord, 30 degrees plus this 48 degrees that is between the tangent and the chord that is subtending it. Same 78 degrees. All right, that is that. Hold on a second, guys. Hold on a second. All right, ready? So somebody wanted the bearing question on this paper, right? Yes. Right here. All right, let's go. Question says, E, F, G, and H. If I'm going to talk, I'm going to ask them to leave, you know. E, F, G, and H are 4 points on level ground. The diagram below gives information on the distances and angles between the points. So these are on level ground. So it's as if you're up in the sky looking down on these points on the ground. Just imagine that. All right. It says, show that the value of x to 1 decimal place is 29.5 degrees. So x is the angle inside here. So to find x, we're gonna have to come and work in this triangle. Now, firstly, that triangle is not a right angle triangle. So we cannot use so-called tower in it. We also can't use Pythagoras' theorem in it. We can only use the sine rule or the cosine rule in that triangle. Once you have a triangle with 3 sides, I don't know the angle, it's not a guess or spell thing. You have to use the cosine rule. Because remember, in order to use a sine rule, you must have a pair of angle and side that are opposite to each other, where you know the two values. You know the angle and the side. You must have that known pair of angle and side opposite to each other to use the sine rule. If you don't have that, you have to use the cosine rule. So the one angle that we want, we know the side opposite. In fact, we don't know the angle, so we don't have no pair of angle and side opposite each other. We have to use the cosine rule. Now, if we're going to use the cosine rule, you have to now start to imagine the setup of the cosine rule, which is centered on 2 sides and an angle between. I'm going to stop the talking. Two sides and an angle between. That's the setup of the cosine rule, set up on that premise. And it is as if you're trying to find the side across from the angle. So I really should have put this in blue. And so that is the setup. So just think of it initially as if it is Pythagoras' theorem and this is the hypotenuse. Cosine rule starts out that way, as if starts out like Pythagoras' theorem. Like you're trying to find the length of the hypotenuse, and it's as if this was the 90. The angle opposite here was the 90, and this was the hypotenuse. And you were trying to find the hypotenuse. That's all cosine rule starts out. We don't need to look at no formula. Just set it out like cosine rule initially. And you know, so for the cosine rule, set it out like Pythagoras' theorem initially. I know that for the cosine rule now, you're subtracting a piece, which is the 2 times the product of the 2 sides. That is not the hypotenuse, times the cosine of the angle between them. So if I'm going to do this now to find this angle, I have to set it up first in the cosine rule, lay it out like the cosine rule. But then remember now that cosine rule starts out like it's Pythagoras' theorem. So Pythagoras' theorem would have said, treat this like the hypotenuse, the side opposite the angle, as we're working with, treat it like the hypotenuse. It would have said 6.9 squared. The hypotenuse squared is equal to the sum of the square of the other 2 sides. The 5.3 squared and the 11 squared. That would have been Pythagoras' theorem if this angle was a 90. It's not 90. So you have to subtract a piece. And you all know the piece you subtract is twice the product of the same 2 sides here, the 5.3 and the 11, times the cosine of the angle. That would have been the 90, but it's not 90. Cosine rule can use Pythagoras' right angle triangle to if the angle is 90. You know. Just that the cos of 90 is 0. And all of this would have become 0 if this angle was a 90. You get me? Cos of 90 degrees is 0. And all of this would have just become 0. And I end up back with Pythagoras' theorem right here. All right, but anyway, that's what we have. So we put in the cos of x. So we have that. So now it's a matter of transposing this expression to find the x. Now some teachers or some people will say, you work this out, and you work that out, and you work this out, and you work that out. You can't bother with that. Me want to calculate one time. The question don't give you a lot of space a lot of the time. So well, this time they give you a good amount, but a lot of the time they don't give you a lot of space to do the same thing. You might look at another paper and the amount of space you have is just that. And we have seen that. So we have to be able to look at this and transpose to make this the subject, in particular the x, the subject. So you can just do one calculation. All right? So look at the steps now. I just need to do it one time with this, and you can do it with any other case, 3 sides, and you want to find an angle, cosine rule, and you're transposing to make this the subject. So the first thing I'm going to do, I'm going to take all of this that is negative, bring it over here and make it positive. So like I'm moving all of this and bring it over here, it's going to become positive. I'm going to take this 6.9 squared and bring it over this side and subtract it as well. So the positive 6.9 on that side going to go on the right side and become negative. And all of this expression over here, which is negative, going to go over there and become positive. Look at it now. Easy transpose. So all of this coming over here and becoming positive. Let me write it out for you. 2 times 5.3 times 11 times the cos of x becomes equal to, this no move, 5.3 squared plus 11 squared. But this now goes over there and is now negative. So we'll subtract this, minus 6.9 squared. Simple. Remember, this I want to leave as a subject now. So I now need to move this. How do I move that? Divide both sides by it. Or shortcut, we take it and we divide it under this side. I am literally going to move it. Let me write the next line. So I'm going to take this and divide it under here. So I'm going to end up with, as I have a space, I'm going to do it this time. Cos of x equals all of this again. 5.3 squared plus 11 squared minus 6.9 squared. All over the whole of this now come under here, so we divide it. So you put in the 2 times the 5.3 times 11. That's why you need a good calculator. A lot of people go and type this out here, so, and then put divide by 2 and then start put times, which is going to give you the wrong answer. Promise you. All right. Each of these dividing. So if you're going to calculate this with the full calculator, then you have got to put this in the calculator first, and then you have to bracket it. See it as one term. You have to divide by the 2, divide by the 5.3, and divide by the 11. Each of them dividing. All right. But the safe thing to do is get the good calculator that you can put this all in. Right? Then now, to leave x as a subject, I'm going to do cos to the minus 1 in front of this. Cos to the minus 1. I'm going to write the step again. So I'm going to get now x equals cos to the minus 1 of all of this expression. Let me write it out for you again. 5.3 squared plus 11 squared minus 6.9 squared. All over 2 times 5.3 times 11. And you put everything in the calculator and you're going clear. It's 2 marks for it, but don't matter. It's 2 marks for it for everybody who's doing it. Like it's 2 marks for you and it's 5 marks for somebody else. Do not worry yourself about things that you can't control. It don't make no sense to worry about marks. It's the same marks to everybody. Sometimes, believe me, sometimes after the exam paper reach the examiners or the markers will say to them, no, this is not fair. This mark not fair. And they will change the mark scheme sometimes. It happens. You understand me? You don't know what you said about marks. Just work the question them. For 1 mark, 1 hold something value, you want the 1 mark. So I want to put this in the calculator now, and it's going to just work out to the 29.5. So let's look at it now. And listen now, you don't need to do 10 of them. All that will happen with another question that the values will be different. It's the same steps. Do it with this one. Do it comfortable with this one. And any other one you get. And I said I set it at least 2 or 3 times in recent time. We have to find an angle given 3 sides. You have to cosine root to find it. All right. So get yourself comfortable with it. So it's cos to the -1 of a fraction. Set it out exactly as it appears there. 5.3 squared plus 11 squared minus 6.9 squared over, that is 2 bracket 5.3 close bracket open bracket 11 close bracket, see? 29.5 on the calculator. 29.5 degrees shown. You don't need to do 10 different questions with this. Do this with this one and any other one you get, where you need to use the cosine root to find an unknown angle in a triangle that is not right angled, and you have the 3 sides. That is it. Same process. All right, that is that. Next part now says, it says a vertical tower. So this is vertical. Now, remember, I know everything in this diagram is horizontal. You know? Everything in this diagram is horizontal. They're on the ground. So they put a vertical tower G right here. That's what they said. A vertical tower GT is constructed at point G and is pivoted to the ground at the points E, F, and H. Right? Using pieces of wire. I don't know if you've ever seen a vertical thing like those antennas and those cell towers, and they have wires coming off them down to the ground. It's a similar sort of thing. Right? So right at this point G here now, they put a vertical tower, but you can't see it in the diagram because it's like it is coming up towards the sky. Remember, you're up in the sky looking down on the ground, you know? So the T is on top of this G. Right? The T is on top of this G right here. At this point, the T is on top. So you have a tower right here, looking at the top of the tower, and that is the G. Right? And that vertical tower now is pivoted to the ground at these 3 points. So if I kind of show it from the side, then it's like you have this vertical tower somewhere here, and you have the points around it, right? I mean, you have the points around it. And these points are on the ground. These points are on the ground. And from this vertical tower now, they have strings down to these points, like so, from the top. But these lines now are still horizontal. I draw them in purple. This is horizontal, and that is horizontal. Those purple lines are on the ground. I just making out a sketch. So because this is vertical and this is horizontal, it means that the angle right here so is 90 degrees. Angle between horizontal and vertical is 90 degrees. Similar angle between this and this is also 90 degrees. I'll show it like this now. And the angle between this and this line is also 90 degrees. I'll show it like this. All right, and they said this is G, this is T, and out here says F, and that's a vertical wire. Now, if you were to look at this now from the side, look at it from the side, then you will see the vertical pole. You see this GF on the ground, and you see this wire connecting the top of the pole to the ground. And right here is 90 degrees. Look at it from the side. So this is called elevation view. This is a G, this is the T, and this is the F. That's what I talk about. The angle of elevation. The angle of elevation at the top of the pole T from the point F is 31 degrees. So the angle looking up here is 31 degrees. Same thing. If you look at this diagram, if this is our F, then it is the angle up here, looking up here, that is 31 degrees. So over here, put on the elevation view, this is a 31 degrees looking up. And what was this distance? They gave us this distance. That distance was 6.9 meters between G and F, 6.9. So this distance here is 6.9 meters, right here, 6.9 meters. And the question is asking us now for the length of the wire. They could have also asked for the height of the pole or the tower. But this is now a right angle triangle. We have one side and we have the angle. So we can use so-called tower in that right angle triangle now. Just like the one, the length of the wire this time. Right? I've seen questions where they've asked for the height of the tower. All right, so let me take this off now. So that's a sketch of what is happening, right? That's a little sketch of what is happening, like an elevation view of what is happening. So we're working out the length of this wire. Let's call the length of the wire L. The length of this wire, we're gonna call it L. We can't use X because we have X in the question already. So because the one L, so-called tower. So which one are we gonna use? We have so-called tower because it's the right angle triangle. And in this question, we know the adjacent. Since this is the angle we're working with, you know, this is the angle under consideration. We know the adjacent to it. This is the hypotenuse. The L is the hypotenuse. So what are the sides involved? We know the adjacent and we are trying to find the hypotenuse. So we're going to use cos. We can't use this because we're not using the opposite. We can't use it because we're not using the opposite. Adjacent and hypotenuse are the sides involved. So we use cos. So it's simple now. When I say the cos of the 31 degrees, set it up now is adjacent over hypotenuse. The adjacent is 6.9 over the hypotenuse is L. And then you're trying to find the L, trying to make L the subject. So we're just going to multiply the L up here and divide under cos 31. Simple, cross multiply and divide. So the L then becomes 6.9 over the cos of 31 degrees. And work that out. 6.9 over the cos of 31. Now let's just say if they wanted the height of the tower instead. Let's just do that under here. I could have asked it as well. So if they wanted the height of the tower over here, then this would have been the opposite side, and this would have been the adjacent side. Adjacent tower. I write the wrong thing in there. This is tower, OA. I couldn't tell me. Go to me, I'm going to do the tan one. So-called tower. Right. So if that was the case, then I would use tan because I would want the opposite and I would know the adjacent. Opposite and adjacent would be the sides involved. Right? So in that case, if you wanted the height of the tower, then we would have said tan of 31 degrees equals the opposite side, which is the TG, over the adjacent side, 6.9. 6.9. And then to find the TG, would have just multiplied by 6.9, and the TG would have been equal to 6.9 times the tan of 31 degrees. All right? And so this is the calculation that they really want. I will tell the examiner that we'll call it L in the diagram right here. So I'm going to say equal L. So examiner know that when I find L, I found my answer. I'm working this out. So the L will be equal to the calculator. It's a fraction, 6.9 over the cos. Where's the cos? Cos of 31. 6.9 over the cos of 31. Right there. And that gives us 8.05 meters. This is 8.05. I'm working in meters. They didn't ask for this, but if I asked for this, the height would have been 6.9 times the tan of 21. Let's just finish it. 6.9 times the tan of 31. Height would have been 4.15. 4.15. So TG would have been 4.15 if they wanted it. TG would have been 4.15 meters if they wanted the height as well. So this is a if. Right? They didn't ask for this. So this is the answer of the question. Right here. All right, let's go to the next part now. Back to the bearings. So this part now says, let me shift this, make it smaller and shift it up, this thing. All right. Down here now says, the bearing of E from H, must always note the from position when you're doing bearings. So it's from H to E. The bearing is measured at the from position. It is 228 degrees, and the bearing must be measured clockwise at the from position from the north line. So I'm going to draw that angle on the diagram from H to E. Let's put on the diagram from H to E. So this is a from position. You're trying to come down to E. You want the bearing from here. So this is our north line. The angle that you want is this one. All of this one here. That's the angle that is 228. 228. That angle is 228 degrees from this north line. All right, that's what they gave us. Remember, so we know the X and we know this now. We know the two of them, right? We know the X and we also know this, right? Question says, down here, find the bearing of H from E, the other way. So we're going from E back to H. We just show that bearing angle on the diagram. From E to H. Let's look at the diagram now. We want the bearing from here back up to there. All right. Show you a nice way to do this one now. Watch this. Show you a nice way to do it. If you watch a video, it is already there. You see I do it maybe a different way from this. Let's do it this way. That comes to mind now. Now, firstly, the bearing that they want, this is the north line. The bearing that they're asking us for right now is this angle. From E up to H, clockwise from this north line, is this angle. That's the angle that they want. Now, a quick way to find that angle is to actually find this one first, which will be 360 minus that. Right? And then remember that these two angles are co-interior angles, they add up to 180. So if you look at the video, so we do it that way. But let's look at another nice way to do it. All right. So let's look at it. Another nice way. So we want this angle inside this, right? So this line is forever on this bearing, you know. No matter where on the line you are, it is on that bearing. So this same line, because bearing really is a direction thing, you know. This same line from E to H, this is the direction of it. I'm marking out in blue. I can take that direction and extend it. It's the same direction up here. Same direction. This is the same direction as this line down here. So the bearing of this line at this point is the same bearing it is at this point up here. So it means that this angle up here is the same bearing angle that they want down here. The same bearing angle. But I can say that this angle up here that I've marked is the same angle down here. You could use corresponding angles because these angles, these two lines are parallel and this is one straight line passing them. So you could use the concept of corresponding angles. But the bearing direction of that line is the same everywhere. If I put an outline right here, this angle is the same bearing angle as this. So the bearing angle really is a measure of your direction as well, the direction of the line. So if you want to find this angle up here, so look at it. The whole around here so is 228. Right? And from this blue line to this blue line is 180. So the angle up here that we want, which is the bearing angle, becomes 228 minus 180. But you can see that? Y'all can see that? That is the bearing, because the same angle that is down here that you want. That's a nice way to do it. I'm going to leave it that way. 228 minus 180. 228 minus 180. So if we do it the other way, we're going to get the same 48 degrees here. But because it's bearings, I will put 0 in front of it, guys. You have to put 0 in front of it because it's bearings. Bearings must always be given with 3 digits. Put a 0 in front of it. So the bearing is 0.28, 0.48. So let's write it out down here. So that bearing angle becomes equal to 228 degrees minus 180 degrees. You have to put 0.48 degrees because it's bearings. As I said, the other way to do it, I'm going to show you quickly for the benefit of those who might want to do it this way. The other way to do it in purple, is to say, okay, this angle right here becomes 360 minus 228. Because total angle around this point H is 360, and all of this is 228. So the rest of it here must be 360 minus 228. So this purple angle right here, so now, is 360 degrees minus 228 degrees, which then works out to what? 360 minus 228, 132. And then these two angles now are what we call co-interior angles. They add up to 180 degrees. Why are they co-interior? Because they are like angles in a U. So down this parallel line, up this transversal line at the base of it, back up this parallel line. So they are like angles in the U, at the bottom of this U. Right? They add up to 180 degrees. They're called co-interior angles. So because they add up to 180 degrees, and I'll do this now. This one is 132. Then this down here that you want inside here now, which is bearing, would have to be 180 minus 132, which will give it the same 48 degrees. I have to put the 0 on it same way. All right, so we could get it that other way. I think a lot of person would have opted for this way. But this up here is a nice, cute way to do it. All right, let's continue. Then down here now, they want the bearing from H to G. Remember, we must always note the from position. So from H to G, from H to G. So the bearing again is being measured at H. So look at the diagram here. The bearing is now being measured from H. Let's mark that angle that I want now in purple, in green. So it's from here down to, from H to G, them say? To G, to here. That's what they want, right? To here. So the bearing angle that I want is therefore this one. So on to this line, right? H to G, on the bearing of this line from this position. So it is this angle that I'm marking out in green now, right here. This angle that I'm marking out in green, clockwise from the north line. So it becomes the 228 minus the 54. See that? This green angle that is left in here that we want. This angle in here is the bearing that I want. This angle in here is the bearing that I want. The whole thing is 256. The green angle, you subtract the 54. So this angle that I want is 228 degrees minus the 54 degrees. That is the bearing angle that I want right there. So it is 228 minus 54. 174 degrees. 174 degrees. I can leave that. 174. Alrighty. That is that. Huh? Huh? If I ask question, what time is it now? 9 o'clock. Oh, somebody asked me to do 2022. I'm going to do it before I leave. If you know I leave, I can go on. More maths equals better maths. All right. I'm going to do it before I leave. All right. So this we say it's what? 228. This equals 228 degrees minus 54 degrees. If you never give me so much problem, what I done long time. I'll give me too much problem, man. I'm too restless, man. If you learn to calm, man. It's my Monday and I can't relax. All right. So that is it. That finishes this paper we're doing. Right? Remember, the video is there for the paper, you know. The video is there. So process can go on today. But let me do the 2022 question for somebody online asks 2022. So let's go and do that one. Which question on 2022 you want, boss?
I want the.
Is what the January one?
I think it's in May. Hold on. So yeah,
so remember
2017.
Huh?
2017.
No man, that is for tomorrow. That is for tomorrow. Bring that tomorrow.
All right.
No. The person is asking for another paper. I'm telling him bring it tomorrow. So tomorrow, the session for tomorrow is just going to be straight working out tomorrow between 11 and 5. And it's going to be you bring the questions that you want me to do from the past papers. I say go back to board, don't go past 2015 because I want to be able to do the papers that I can write on the paper. In fact, let me check it right now. Find which paper, tell me which paper you want to do there. You don't tell me whether it's January or June yet.
June.
Well, I'm going to check 2015. Hold on a second. I'll tell you which paper. I want to make sure it's a paper that I can write on. Let me look at 2015. 2015 is the last set. I think 2014 for sure you couldn't write on the paper. All right, good. So from 2015, guys, you can bring questions from 2015. January and June 2015 up to 2024. Any questions from those papers? I wrote them out for you tomorrow.
But the thing is, I won't be here tomorrow. I'll be at our next maths class.
Yeah, man, that's all right. Well, it's all recorded, so you know you have to do what you have to do. What you have to do. All right. 2022. Which one? June, I say. June.
Yeah.
June. All right, which question you want on this one now?
2.
Number 2?
Yes, sir.
Number 2. This one? All right. It's a factorization. Factorize this completely. All right. So because let's use the method. Let's use shortcut first. Because this first value is a prime number. So we're talking now. Because this first value is a prime number. You know automatically that all the factors of this number is 5x squared, or that term is 5x and x for sure. They know that is factors of this that's coming inside this bracket here and here. This plus, because it is positive, it means that the sign of the two values, the two factors, will be the same. They are both negative because the middle term is negative. All right? And it has to be such that the factors of the 4 coming here and here has to be such that the far product and the near product add to the middle term. So let's say I try 1 and 4, because the only factors of 4 is 1 and 4 and 2 and 2. So let's say I try the 1 and 4 first. And let's say I put the 4 here and the 1 here. No. Put them the wrong way around first. Let's say I put the 1 here and the 4 here. Then the far product will be 20x. And the near product will be 1x. 20x and 1x is 21x. But my middle term is just 9. So it means that the values are not in the right place. So if I try them the other way around and put the 4 here and the 1 here, then my far product is 5x and my near product is 4x. Those add to 9x. Just that now both of them have to be negative. So I have to put 2 negatives in the bracket and that will be it. So it will be negative 4x and negative 5x, give me negative 9x. Now let's say I put a 2 and a 2. The other factors of 4. Let's say I put a 2 and a 2. show that it will be wrong. My far product would have been 10x. My near product would have been 2x. 10x and 2x is 12x. My middle term is just 9x. So you know that the 2 and the 2 could not work. So by simple almost elimination, because of the prime, you automatically know this 2, it becomes easy to do almost like by trial and error. So we put in the 4 here and the 1 here. Signs are the same, they are both negative. Minus, minus. That's a quick way to do it. All right, using almost like trial and error. So I'm gonna put this up here now under the method approach. All right, the method approach is to split this middle term. How do you split them? You first multiply the n coefficients, which is the 5 times the 4 equals the 20. Then you're looking for factors of this 20 that add to the middle coefficient of a negative 9. So look at the reason now. You want factors of a positive 20. Factors of positive number is either 2 positive numbers or 2 negative numbers. Since you want the sum to be negative as this, you're going to have to use 2 negative factors of 20. I know it's 5 and 4, but let's say you don't see that it's 5 and 4. You can go down the list of factors until you find them. So the first 2 I would try is, say you try 1 and 20 as the first 2. I make both of them negative. They actually add to negative 21. That's not what you want, because the middle term is actually negative 9. The next 2 factors of 20 will be 2 and 10. 2 and 10. And let's say you make them negative again, because the sum have to be negative and they both have to have the same sign. So you make them negative again. But these now add to negative 12. Not negative 12 you want. You're looking for negative 9. They go 3 and what? 3 and nothing. You're not using fractions, you're using whole number factors. The next 2 whole number factors will be 4 and 5. You make both of them negative, and now they add to negative 9. They add to negative 9. So good. You have found the factor that they're going to use. So it means you're going to split this negative 9x into negative 4x and negative 5x. That's what it means. So you can factorize by parts. So you must see that this method longer, you know. Easier way, you almost use trial and error when the n values are prime. But anyway, I want to split this out first and put the 5x squared, split this into minus 5x and minus 4x, and put back this plus 4. So this minus 5x came from this factor, and this minus 4x came from this minus 4. All right, I deliberately put the 5 in front to factorize with that 5x squared there. Could I put them the other way around as well? They go for the highest common factor in these 2 terms. That's a 5x. So factorize the 5x out of those 2 terms. Out of this, you're left with an x. Out of this, you're left with a negative 1. The same thing that's in the bracket must appear back over here, the x minus 1. So I usually say, put that back first, x minus 1. Then in between here, you must have a plus value or a minus value. How you know what that value is? You can, for example, divide this by this negative 1. 4 divided by negative 1 is negative 4. Or you can divide this by this x. Anyway you take it, you're going to get negative 4. And what it is now is that this x minus 1 is a common factor. See, we have it here. And it is these 2 that are multiplying with that common factor, the 5 and the negative 4. And so if you factorize, you're going to get the 5x minus 4. That's a 5x and the minus 4. And that's why I need to put a plus or minus value in between here. For the common factor of x minus 1 times x minus 1. And these same values that we have here. And if you did it away and got it x minus 1 in front, no problem. Same thing. That is still correct. So it's this or this. All right, so this would work as well. Same answer. We get them that way around. Then it says now, hence solve this. Hence means that we have to use this result. What it is that this side is this. Factorize this to that. So we can write this side as the factors. 5x minus 4 times x minus 1 equals 0. Then notice that this equal to 0. Let's write it out. The 5x minus 4 equal to 0, or the x minus 1 equal to 0. I don't need to write this to it, but just doing it this time. Then to find the x, I'm going to take the negative 4, carry it over, it becomes positive, and then divide the 5 under it. So the x on this side is going to become positive 4 over 5. Or in this case, I want to make x a subject, you transpose at negative 1, becomes a positive 1, x equals 1. So those are your two rules for that. But this one, it says make v the formula, make v the subject of the formula, this v. So to make v the formula, the subject, you don't want them to be dividing each other. You want to multiply them out into separate terms, and then group everything with v on the left side and everything else on the right side, and then factorize away the v. So we're going to multiply this denominator over here by this w first. So multiply this denominator over here by the w. It's going to be the w times the v first. That is wv. And then w times the negative 3. That's minus 3w. And that becomes equal to 5 plus v. Then I want this v over here with this one. And I don't want this 3w over here. Don't have any v in it. I want it over that side. So I'm going to leave v, wv. Then this v comes over here, becomes a negative v. Equals, this 5 is there. This minus 3w goes on that side, becomes a positive 3w. And all we need to do now to get one v in the expression is factorize the v from these two terms. So you factorize out the v. Out of this, we get a w. Out of this, we get a negative 1. We factorize the v equals still 5 plus 3w. And then there's a matter of taking this and dividing it under here. Same as say divide both sides by w minus 1. And this one cancel. For the shortcut is to say the w minus 1 over here is multiplying. You divide it on this side. So the v becomes 5 plus 3w over w minus 1. All right, that is that. All right, next part. Next part says, it says the height h of an object is directly proportional to the square root of its perimeter. That's a variations question. So the height h as the first variable h. Directly proportional means it is k times a constant times. The second variable is the square root of p. Square root of p. That's a relationship. Because direct. If it was inversely, it would be k over the square root of p. If it was inversely, then h would be k over the square root of p. If instead of directly here, they had the word inversely. But that is it. First question says, write an equation showing the relationship between h and p. This is it we have right here. I'm just going to move this down. That is it. That's what they want. All right. Remember, the k is a constant, a value that is not changing. Connects the h and the square root of p. It's not changing. Down here it says, given that when h is 5.4, the p is 1.44, determine the value of h when the p is 2.88. Now, for this question, you can actually use these two values, substitute them in there to find the k if you want. But that really is a waste of time calculation. Okay, you're not getting any marks for calculating the k. You don't need to find the k. Some questions will ask you for the k, some questions will not ask you for the k. Because this one don't ask for the k, I'm not going to calculate the k. What I'm going to do is make k the subject, and that subject is always a constant. It shows me what relationship between the h and the p is constant. So how do I do that? I'm just going to take this root of p and divide it under the h. And so what it means that the k is always equal to the h over the square root of the p value. So this pair of h and p, gives us the same K when we set it up the same way with this pair of H and P. What it's saying is that the H over the square root of P is a constant value for any pair. This is one pair. It equals the same setup for this pair. So let's write it out. All right? The K, a constant, what is a constant? Is the height over the square root of the P value everywhere. So this height over that square root of this P, over there, this one, this height, which is 5.4, over the square root of this P, is equal to the same setup for this pair, because a constant. So it is this H that you're trying to find over the square root of this P that you have. And so now you have an equation that you're trying to find the H. So to find this H, all I need to do is take this and multiply it up here. I multiply it up in front here. So we can set it up. The H becomes equal to 5.4 times the square root of 2.89 over the square root of 1.44. That's what I get when I multiply this up here. So when I work this out, I have my H. So I can say, therefore, my H is equal. Let's work this out, and that's my H. I did not need to calculate the K. Some questions will ask for the K. If I ask for the K, all you have to do is plug these values in that and work out what the actual value for the K is. But I don't need to work it out. All right? I don't need the actual value of K. I'm just going to set up this. It's 5.4 times the square root of 2.89 over the square root of 1.44. So that's 7.65. 7.65. That's my H. End of this question. All right, guys. That is it for today. The videos are there. You can all go and watch the videos. All the questions on these papers. And tomorrow we'll have a session 11 to 5. Bring your questions tomorrow. Look here. Don't leave no garbage in the classroom, please.
All right, bye, sir.
All right, cool. Bye-bye. Don't leave any garbage in the classroom.
Bye, sir.
All right, bye-bye. Somebody else was saying something before we end? But all right? All right. Tomorrow again at 11 o'clock. All right. Tomorrow again at 11 o'clock. Right, bye-bye. Don't leave no garbage in the classroom, please.